Welcome back to the Pearl Report. The world is getting hotter due to global warming. So how will rising temperatures impact Hong Kong's native animal species? Renato Reyes reports scientists fear some of the city's marine creatures will become locally extinct. Shan, a village in Yuen Long famous for its main attraction.
Oyster farming, and there are many people especially come here for getting the oyster.
Ginger Ho is a marine researcher here to get samples of Hong Kong's native species of oyster, Chrysostrea hongkongensis.
I normally come here and get oyster for our experiments.
The Swire Institute of Marine Science on Cape de Gila is studying Hong Kong oysters after farmers revealed a curious phenomenon.
They are smaller in size, and they are also struggling for the survival.
The quality of meat is not the same as they were seeing before. It's not tasty.
It is the Hong Kong local oyster. We will get the adult oyster, and then we will take out the sperm and the eggs from the females and the males, and to mix them in the water to create the larvae. The larvae will develop after 24 hours.
We have a carbon dioxide.
Carbon dioxide is pumped into these jars of seawater to culture the larvae.
To mimic how they can survive under global climate change conditions.
Seawater replete with carbon dioxide is causing a huge environmental disaster that could wipe out many marine species worldwide in the next 100 years. Ocean acidification.
Our Victoria Harbour already saturated with carbon dioxide.
The more fossil fuel Hong Kong burns, the more carbon dioxide it emanates into the atmosphere. A third of that is absorbed into seawater.
This is the global average, 380 parts per million. Our carbon dioxide over 600 ppm, which is extremely high.
Carbon dioxide alters the chemistry of seawater, making it more acidic. pH is a measure of acidity. The lower the pH, the more acidic the water. The global average of the planet's ocean is 8.1 pH.
It's already 30% acidic than 100 years ago.
The seawater is 7.9 pH. It's acidic partly due to pollution from the Pearl River Delta.
Extremely acidic than global average.
Dr. Tia Garajan heads the experiment.
This is the controlled current seawater condition. So the pH you see 8.1. Within 100 years of time, you see your pH is decreasing. It's already 7.5. The larvae are growing there. So we're just studying them how they are growing and under this low pH conditions.
Scientists observe the larvae's first 15 days.
They do form shells right after 6 hours from fertilization.
But in the acidic water, scientists find the larvae are struggling to grow shells.
They take 2 more days to grow to the same size of the oysters that is being grown in normal conditions.
Oysters stay in the water for the first 2 weeks before settling on a rocky surface for the next 4 to 5 years.
If they stay more in water column, they might have high chances of being eaten by animals. This will in turn will slow down the population at the ecosystem level. We are looking at the proteome of the Hong Kong oyster larvae.
The DNA of its protein. All oyster species have a breaking point when they can't take the acidity anymore and die. There are 3 main oyster species being farmed in the region: the Portuguese oyster from Taiwan, the Pacific oyster from Japan, and the Hong Kong oyster. These 16 water tanks have various levels of acidity.
We have 16 scenarios for them to choose. See which is the best condition for them, which is the tolerable level, at what pH they collapse. Who is going to be the winner? Who is going to be the loser? If we go below 7.7, which is what we are expecting in next 100 years of time, you lose your Hong Kong oysters because they are highly sensitive to small changes in the chemistry. The Pacific oyster and the Portuguese oyster can tolerate much lower pH than Hong Kong oyster. So, for example, Hong Kong oyster will die at 7.4 pH, but they won't die. In the United States, in Europe, Canada, oysters already declining. Oyster industries in US collapsed.
I traveled to the northwest coast of US to see what is happening over there. The pH of the water is acidic. And when they pump these acidified waters to their hatcheries, they can't get a full yield production. The larvae still dies. They don't know what is happening.
At any time it may happen to China as well. We just simply don't know when.
China supplies 70% of the world's oysters. 30% of them are Hong Kong oysters.
90% of the larvae die before they reach adulthood. That's just the nature. So we can't afford to increase this number to 95, 96 because of the extra carbon dioxide we are producing in the atmosphere. There's millions of villagers' livelihood depend on these oysters. If we know how to save this oyster, then that means we are saving millions of poor fishermen.
Rajan and his team are helping oyster farmers alter water chemistry to the optimal level for culturing larvae in hatcheries.
We can add a lime into it, dilute the acidity.
How about the city snails and mussels?
So here are some of the snails which we're working on.
SWA Institute of Marine Science Director Gray Williams is studying whether snails on the shore could survive a warming planet and at what temperature.
Which species can cope and which ones can't cope. This is what we call an eye button. Basically, it's a data logger that you can actually record temperatures with.
The button is put inside an empty limpet shell. These robo-limpets are placed on the shore to record rock surface temperature, the heat snails and mussels feel inside. Hong Kong averages 28 degrees Celsius in the summer, but these snails can bear twice that temperature on the shore.
They can tolerate rock temperatures of over 50 degrees Celsius. The tide drops, they sit down, seal their shells to seal the water resources they have, and so they can survive being out of water for days on end. They just feed when the tide washes over them.
Hong Kong snails can beat the heat, but how about its native mussels?
Hi Michelle, how's it going?
Increasing the temperatures and see how their heart rates would increase with the temperature.
This is the black mussel and the green-lipped mussel. Both are exposed to different air and water temperatures. A sensor is attached to their hearts.
There's another beat, there's another beat. As they get hotter, their heart rates will increase. But we can also detect at which point the heart starts to fail. The heart will start to beat irregularly, or it will start to slow right down. That means the animal is starting to experience stress.
And the loser, the black mussel, dead at 40 degrees Celsius.
We have die-offs of this animal that take place in the summer because we do get rock temperatures which exceed the tolerance limits.
He believes the black mussel is already retreating northward towards Japan and predicts it might become locally extinct in the next 20 years.
It'll be too hot for them and they won't be able to replenish themselves after a kill-off in the summer months. Lots of animals live amongst the mussels. If you remove the mussels, you remove a lot of those animals. So again, you lose biodiversity.
The good news, this seafood staple is here to stay.
The green-lipped mussel, I think that will actually become more predominant because it likes the hot weather.
Would Hong Kong's butterflies still be around in the next century?
Oh, where'd they go? They all disappeared. Butterflies, their upward thermal tolerance isn't very flexible.
In one experiment, a heated wire is inserted into the thorax of a butterfly to measure how much heat its body can take before it dies.
When the body temperature of a butterfly goes past roughly 40 degrees Celsius, give or take, they'll die.
Tim is doing research in the field to back up a theoretical model he'd done that showed butterflies in the tropics were more vulnerable than those in colder areas.
The most negative impacts that we project here are occurring in the Amazon basin, for example, in the Afrotropics and in Southeast Asia. You can see here the Indonesia, and Hong Kong is actually right in the margin of the tropics. If you can imagine an organism living in a hot environment like the tropics, they're going to be closer to that maximum physiological limit. If it's hotter than basically their maximum thermal limit, a lot of species can't tolerate warming past this limit, even 1 or 2 degrees of warming, because it's so hot already.
His study will take decades, but it's the first step in a long journey to chronicle a looming environmental catastrophe.
Most butterflies live most of their lives as caterpillars, an important food base for birds, mammals, lizards. Will lose the species that depend on them.
Well, thank you for watching our show. It will be re-aired on Tuesday and Saturday, as well as on tvb.com. Until next time, from the Pearl Report team, good night, good luck, and good health.
Some